Hi guys, welcome to lesson 12.6, Permutations and Combinations. Our objective for the day is to find permutations and combinations. And for the record, we are skipping 12.5. We may come back to it later. Alright, so the multiplication counting principle for problem number 1 says that if there are m ways to make the first selection and n ways to make a second selection, then if we multiply them together, we will know how many possible combinations there are. So, for 5 shirts and 8 pairs of shorts, you can make a combination of 40 different outfits. Pretty cool. Alright, so letter A. A pizza shop offers 8 vegetable toppings and 6 meat toppings. How many different toppings can we order with 1 meat and 1 veggie option? And we have 8 times 6 is 48 different pizzas. Letter B, the 2016 Toyota Corolla is the world's best-selling car. If there are 10 paint options and 7 interior options, how many possible combinations are there? 10 times 70 is 10 times 7 is 70 possible car combinations. Letter C, during the Pi Day breakout, one of Mr. Boland's hooligan algebra students changed the combination on one of the 3-digit locks. How many possible combinations would Mr. Boland have to try to unlock it? Well, if we remember, those combinations had 10 digits. They were 0 through 9. So we've got 10 times 10 times 10, which is 1,000 combinations. Not a lot of fun. Do not do that. All right, letter D. This is a little bit of a tougher one. You're required to have an 8-character password. How many potential passwords are there if you only use letters? And how many potential passwords are there if you use alphanumerics, which is numbers and letters? Now, we've got 26 letters in our alphabet, but remember, you can have capital and lowercase, so that would be a total of 52 options. So, for 8 characters, and we've got 52 per character, 52 times 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 52. I guess Ms. Zurzo paid attention in chapter 7 because she knows that 52 8 times is 52 to the 8th power, which is 5.35 times 10 to the 13th possibilities. That's a lot of possible combinations that a computer would have to use to try to crack your password. Now, if we're going to use alphanumerics, we're going to add in 0 through 9, which is another 10 possible characters. So now you have 62 to the 8th power. And that's 2.18 times 10 to the 14th possible combinations. Now, for the record, that's 4 times as many, and that would take a computer much longer to try a brute force approach to cracking your password. And the little joke there of the little sister's password, that actually wouldn't be a half bad password, because you're only remembering 4 things, but you have a whole lot of different combinations there. So the longer the password, the better. And if it's something as simple as a phrase, a word, sentence, something like that, that would make a really strong password. All right, problem 2 is finding permutations. Permutations are an arrangement of possibilities in a specific order. Okay, so we're taking them and the place matters. So, in a baseball lineup, how many different batting orders can Joe Madden create from his starting 9 players? So in that first spot in the lineup, you have 9 possible players that can go there. In the second spot in the lineup, there are only 8 players left that could go into that one because 1 is already on the first spot. The next spot in the lineup, we can have 7. Now we've got 2 that have already been placed. 6, 5, 4, 3, 2. When you get down to the 9th spot, you only have 1 person that you can plug into it. So when we plug all that in, it's 362,800 possible lineups.
I'm going to do something here.
Okay.
Can we introduce that?
Sure. So, we're going to introduce you to a new term. It's called a factorial. And what this means is when you see 9 exclamation point, that means we are doing 9 times 8 times 7 times 6 times 5 all the way down to 1. All right, and that is an easy way to do a whole bunch of math really quickly. And when we're using our classroom calculators, we push the math button, and if we go to PRB, which is probability, our factorial is number 5 there. So we would just take and put in, let's just say 9 factorial. If we hit enter, we will get 362,880. Oh, I miswrote it. 362,880. All right. So that is a shortcut to having to do all of that math and all of that multiplication. All right. So let's take a look. Letter B, we've got a track that has 8 lanes. How many ways can 8 runners be assigned for those lanes? So we do 8 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So we hit 8 and we hit the math button. Go over to probability and it's number 5. And hit enter. So there's 40,320 possible combinations of lanes. Okay. All right. So now using permutation notation, this is written where if we've got more options than we have locations. So you've got, for example, the entire roster of 25 players going into 9 batting slots. You know, that would be, you can't put all the players into the lineup, so you're going to have to pick 9. Well, there's a whole lot of ways that we can pick 9 batters out of that. So this is what we can do to get there. We use the expression NPR. So N is the number of objects that we are arranging. So in the case of our batting example, it would be 25 players. And we are going how many at a time? That is our R. Well, there's only 9 slots in the lineup. All right, so we would punch those numbers in for N and R, and you can do that math if you really want to. But if you happen to notice when we were on that probability page in our calculator, it gave us an option to use this permutation notation. So Ms. Urzo wrote in 25 factorial over 16 factorial. That's going to give us how many possible ways we can take a standard 25-man roster and break it up into batting orders. And that is a giant number. So let's take a look at some smaller examples. We've got a band that has 7 new songs, and they want to put 5 of them on a demo CD. How many arrangements of the 5 songs are possible? So we have 7 objects. There are 7 songs that we are trying to put into an order, and there's only room for 5. So you can do the 7 factorial divided by 2 factorial. Or, using our calculators, we hit the math button again. We go over to probability. Actually, there's one thing first. We type our first number, which is 7. We've got 7 songs that are being arranged. And we want NPR. And so you see it spaced it out there. We're going to put in 5 for the number of songs that we want. Hit enter, and we get 2,520 possible combinations of songs. Okay, so real easy. The way we type it in, we type our first number in, we go to that probability, get NPR, and type in 5. All right, so now we've got, there are 6 students in a classroom with 8 desks. How many possible seating arrangements are there? Other way. So we've got more desks than students, so we've got 8 desks. going into 6 different ways because you're only arranging the students. So we've got 8 NPR 6. Hit enter, and there are 20,160 seating charts that you could come up with using 8 desks and 6 students. That's a lot. Okay, next up there are 6 students running for 3 different student council positions, president, vice president, and treasurer, and we want to know how many different ways those 3 offices could be filled. There are, other way around. We have 6 things being arranged, 6 people that are going into 3 possible options. So we go 6, NPR, 3. So there's 120 different combinations of those 6 people running for office. Okay. All right. So next up we have combination notation. And combination notation is when we really don't care about what order the selections come in. It's not like a batting lineup where one person has to go one after the other. They are just going together.
I always think of pizza. It doesn't matter whether sausage goes on first or the pepperoni, as long as they both go on.
Okay.
Pizza combinations.
All right, so we've got 20 people reporting for jury duty. We want to know how many different 12-person juries can be chosen. So again, we can use the whole combination notation and write the n factorial and all that stuff, or we could just use our calculator. And personally, I like our calculator because it does all the work for us. So we've got 20 people that are going to go into 12 different spots, and we don't care. It doesn't matter if you're juror number 1 or juror number 12. So we do 20. Go to our math button, probability. Now we're going to use the NCR, and we need 12 jurors. So there are 125,970 possible juries that can be created with those people. Okay. Next up, we've got how many different ways can you choose 3 types of flowers for a bouquet from a selection of 15 types of flowers. So we're selecting out of a group of 15. We're picking 3, and we want to know what that's going to be. So let's type it in. 15 NCR 3, enter. There are 455 different bouquets. And now we pause from your lesson for an advertisement. May 19th through 21st, Disney's Beauty and the Beast Jr., Huntley Middle School, Clinton Rosette Middle School. It's going to be awesome. Come and see it. Go bother your secretaries in your buildings to buy tickets. They are on sale now, and we are super excited about it. Come see and support all the awesome hard work that your classmates have been doing on the stage and on the singing, the acting, the dancing, all of it. So I really hope you guys come out and see it.
We now return to our regularly scheduled program.
All right, so you've got 10 employees that are eligible for 4 promotions. We want to know how many different ways the promotions can be earned if the order is not important. So again, we're just typing it into the calculator. 10 C4, and
Sorry. C4.
We have 210 possible combinations. All right, and that is the end of our notes for today. We hope you have a great night.